Next, we are going to learn how processes from different computers can communicate with each other. And this slide shows you how the communication can be done in client-server systems. Then the question is how we can achieve this. So we can use a special interface called socket, which is defined as an endpoint for communication in client-server system. Socket is a combination of an IP address and a port number. So one process of the communication uses the IP address to locate the computer host, so where the other process located. However, locating the computer host is not enough to achieve the communication, since multiple processes are running inside the computer host. So we need a mechanism to help us distinguish which process we are going to communicate with. Here we can use port number to distinguish the processes. That is why we use a combination of an IP address and port number, so that we can deliver message to another process on another computer. So when we do the communication between two processes, we need a pair of sockets. The sender or client needs a socket, and the receiver or server needs another socket. So for example, a web browser wants to communicate with a web server. So on the browser side, it needs to create a socket with its IP address and port number. On the server side, it also needs to create a socket with its IP address and a specific port number. So commonly, for the most widely used web services, so they are assigned a fixed port number, so that most of the time, the user do not need to specify the port number. For example, so we will use a port number 80 for the web servers. So you may realize that so when you want to check web page of our department, so you only need to type in the URL, and you do not need to type in port number 80 to specify the port number for it, right? Because of most of the well-known web services, number 80 is the reserved port number for them. So when you type in the URL, the operating system will help you add the port number automatically. And also, the port number below 1024 are reserved for certain network services. So therefore, when you want to assign the port number for your self application, so you'd better to choose a port number higher than 1024. So in order to avoid the confliction with the reserved port numbers. Another thing I would like to mention about the IP is that so there's a special IP address which is 127.0.0.1. So if two processes within the same computer wants to communicate with each other, so both of them, they can use this special IP address combined with a different port number to communicate with each other. So we also call this port number as a local host. So in real world, there are three types of sockets. And the first one is a connection-oriented socket. So you may heard about the term TCP, which is shorted for Transmission Control Protocol. So for this type of socket, when two processes create their sockets, a logical connection has been established between these two sockets so that the process can dump whatever messages to the other side of the socket. And also, this socket is a bidirectional connection, which means the other process can dump message to this side as well. The other type of a socket is a connectionless, so we also call it UDP protocol, which is shorted for User Datagram Protocol. There is no connection required for this type of a socket. So when one process creates a socket, it can dump the message into the socket. However, whether the message can be received by the other process, it depends on whether the other process called the receive operation. So therefore, the message is very possible lost on the path. The third type of a socket is called a multicast socket. So this socket is used for one process wants to communicate with multiple processes at the same time. The sender process does not need to set up the connection with them one by one. It only needs to use the multicast socket and create a socket and dump the message into the socket. And then the operating system will duplicate the message and send them to each process the sender wants to communicate with. Another type of communication for processes located on different computers is called remote procedure calls, so which is shorted for RPC. This RPC abstracts procedure calls between the processes on network systems. So you may still remember how processes sit in the same computer to communicate with each other. Actually, they use inter-process communication, IPC. RPC is very similar to IPC, but for processes on different computers. And also, the port number are still needed to differentiate the services or processes. On both client side and server side maintain a stub, which is a proxy for the actual procedure. So when the client side wants to communicate with the server side or call the functions on the server side, the client will call the stub. Then the client stub will locate the server and also transmit a set of parameters to server side over the network. On the server side, when the server stub receives the message, it will unpack the parameters and performs the procedure on the server. If the procedure generates any output that is required by the client side, the server will use the same strategy to send the output result back to the client side through the RPC approach. When we make a function call, sometimes we need to pass the parameters into the function, and sometimes the parameter could be complicated. For example, we pass a structure as a parameter. In order to handle those kind of a situation, the data representation can be handled through external data representation, which is shorted as a XDL format to account for different architectures. And also, for different operating system, we need to consider different conventions. For example, the big endian and the little endian. Since in computer science file, we use binary code to describe information. For example, an integer, there are higher bit and a lower bit, right? So which bit can be transferred first? That is varies from operating system to another operating system. And also, the remote communication is less stable compared to local communication. So certain percentage of a communication will be failed. So we also need to design a mechanism to guarantee the message can be delivered exactly once. For example, the client wants to increase the counter located on the server side by 1. If the remote communication is failed, the counter won't be increased. On the other hand, if the message has been received twice, the result is still incorrect, right? Therefore, that is another challenge to design the operating system. So in order to facilitate the correctness of RPC, so most of the operating system typically provides a rendezvous, or sometimes we call it matchmaker service to connect client and server. Then let's see how RPC works in real world. So when the client wants to make a remote procedure call, it will call the client stub first. Then the stub will call the kernel to send the RPC message to procedure X. Then the kernel will send a message to matchmaker to find the corresponding port number. When the matchmaker on the server side receives this message, it will look up the corresponding port number for this RPC call X. Then replies to the client with the port P. When the stub on the client side receives this message, it will call the kernel to place the port P in user RPC message. Then the client stub will pack the parameters into the RPC message. Then the kernel can send the RPC call with real content to the server side. When the server stub receives this message, it will unpack the parameters and send them into procedure X through port P. After the procedure finishes the processing, the output from procedure X will be sent back to client through another RPC message. So when the client kernel receives this message, the message will be passed to the corresponding user. The last mechanism for processes to communicate with each other is called PAPs, so which acts as a conduit allowing two processes to communicate. If the operating system wants to provide this mechanism to the user, there are several things that are needed to be considered for the operating system designer. So whether this communication is a unidirectional or bidirectional, if the communication is bidirectional, so whether it's a half duplex or full duplex. The half duplex means that so when A sends a message to B, B can only receive the data. If B wants to send the data to A, B must wait for A finish the sending. Then B can send a message to A. For full duplex, A and B can send messages to each other at the same time. And also, A and B can receive the messages at the same time. Since the communication is between two processes, so do they have a relationship or not? For example, a parent process and a child process. So do we require that or not? And also whether the PAPs can be used over a network or the PAPs can be only used locally. And also there are two types of PAPs that can be considered for implementation on the operating systems. So one is called ordinary PAP. The other is called named PAP. For ordinary PAPs, it allows communication in standard producer-consumer style. The producer can write to one end, which is called write end of the PAP. The consumer reads from the other end, which is called the read end of the PAP. So therefore, you will know that ordinary PAPs are unidirectional because only one end can write and the other end is read only. And also, ordinary PAP require parent-child relationship between communicating processes. For named PAPs, since we gave the PAP a name so that it can make the PAP more powerful than the ordinary PAPs. So in named PAPs, the communication is bidirectional. And also, we do not specifically require the parent-child relationship between the communication processes. And the name PAP can be used by multiple processes. That is why the named PAP are more powerful. Since the PAP has a name, therefore the PAP can be known by multiple and unrelated processes. So those processes can use the name to find the PAP, then through the PAP to communicate with each other.